Build a local LLM-based RAG system for your personal documents. Part 1. Learn how to build your own privacy-friendly RAG system to manage documents with ease. Hey there, are you ready for to transform a mundane private personal documents management into a high-tech AI-powered system that control entirely the local machine? No cloud, no privacy concerns, just you and your documents. Trust me, it's cooler than it sounds. Yes, really. I got the tone of that marketing in me. Today we are diving into the world of LLMs and retrieval augmentation generation systems, but with a twist. It's all about doing it locally and privately, like a boss. So if you know about like just how to do LLMs locally, you could have this cool intro, right? All you have to do is just learn to do LLMs locally. If you can do that, you can be cool like this cool. The backstory why build a private drag system, of course, is privacy. It's going to be privacy. Yes, I can skip this, but I want to read this. If you live in Germany, so if you're living in Germany, you already know the paper struggle is real. So you have a paper struggle, okay, between utility bills, bank. I have heard that there's a struggle for papers. Like in a sense, you get a lot of papers. Uh, yeah, probably between utility bills, bank letters, and tax documents, it feels like we get a mountain of mail every week. The problem, these documents quickly pile up, of course, if you have a lot of, and finding that one piece of information when you need it can be like searching for a needle in a haystack. And sure, while OpenAI's ChatGPT might seem like the obvious solution for a quick search, let's be real. Privacy matters. Of course, matters, but I don't do that. Like I just quickly scan my bills and try to like get things done. But yeah, of course, if you are a privacy person, I'm sure like us, you would be hesitant to upload your sensitive document on ChatGPT. That's where the inspiration for this project came from. Building a personal private drag retrieval augmented generation system on my own machine with full control and privacy by converting all these letters and documents into the PDF and uploading them into the local drag system. That's quite heavy of a manual work. We can now easily find the information we need. No more endless searches. Okay, why do you have to like do a marketing in a like just just I don't know, like just give me the thing, right? Like I know, like I mean, like, who would be this target audience? Like, hey, you know what? Like, I'm going to sell things, but I'm not going to sell anything, but just so that know that by converting all the letters and PDF, uploading this into the local recipe, we can now easily find the information immediately. And of course, we are doing that. Of course, people know about it. Okay, no more endless searches through the piles of papers. Of course, that's what you already mentioned that. Plus, it's free. Who doesn't love that? Okay, you get to chat with the local LLM without worrying about data privacy. Sounds pretty awesome, right? Cool. Here's how it looks. Small demo. Cool. It doesn't have an audio. You can click the upload button. I'm going to follow this mouse. Uh, you're going to chatbot. You're going to click here. I'm not going to. Heute ist der Oktober, welchen Tag habe ich nie bedacht. So ein Kopf und wo findet er statt? Laut dem Dokument, das uh, okay, I did understand that, by the way. You really thought we would display private information as part of the demo? Okay, cool. So that's why it's in German. Like, okay, I like this. The high level rack system design. No, I'm going to do that. Somehow, like, if I do this, you can't see it. Even I can't see it. Like, okay, I can see it now. So this is the flow, I guess. There is the LLM. I found it. Like then you have the prompt. Prompt is actually coming. So here's the prompt template. Of course, prompt template is not the start. Of course, you have the vector database. Then that's not even the start. This is a start. Okay, where does it start? Okay, I think this is where it starts. You have the PDF to text. You have the OCR. Then the extract text here. You clean the text. You have the text chunks, extract entity, extract enrichment. Then the text chunk is turned on embedding. Then there is embedding model which turns the embedding like text chunk into embedding. Then with the metadata, you send it to the document with ID to the vector database to store this. Of course, then you have the top matching chunks, and then you have the user input and chat history. Like this is what it's going to type in, and it goes to the LLM model, and the answer goes back. LLM reply, user input, chat interface is like you have the user interface. You have this interface. So the user input, input also can be uh, thought of as text extraction and embeddings. Of course, it's turned back into an embedding. Then you have a semantic search, hybrid search, BM25. I'm not sure what's a BM25. We will look into it later. Semantic search, of course. Then you search, you get the results. All this. Delete documents with doc ID. I'm not sure why you are deleting. Upload documents. Okay, document with ID. Then PDF, upload new documents. Of course, yeah. Streamlit app. This is the app. This is OCR. This is a RAG ingestion pipeline. Okay. This is a prompt template, and this is all. Okay, that's cool. I think we can move further. Streamlit app. This is where it all starts. Okay, this is where all it starts. It doesn't start here, of course, of course. This is where it all starts. Upload your PDF files using a simple intuitive UI. Okay, this is intuitive. Whether it's contracts, bills, or letters, the app takes care of all interaction without any fuss. You drag, drop, and voila, your documents are now ready for processing. OCR ingestion pipeline. Next comes Tesseract. Next comes PY Tesseract, our tool for converting scan PDF into text. Once, uh, I'm not sure why we need. Okay, maybe okay. This is like actually the PDF actually has image inside it. It's not a text inside it, so that's why we are having those here. Okay, that's cool. Uh, Once the text is extracted, it's divided into manageable chunks and passed through the sentence transformers. Once the text is extracted, it's divided into manageable chunks and passed through the sentence transformers to generate embeddings. For this, we are using German-based model. Okay, German-based model, like there's a German. Okay, from Hugging Face. Why does it have to be German-based model? Like German-based model, mixed breed AI, DeepSet, MX, Embed D large version one, Hugging Face. Okay, cool. Hmm. Indexing with open search. With extracted text, embeddings and additional features are stored in OpenSearch index, which makes the document retrievable really fast. We have set up a hybrid pipeline that uses both the text. Okay, I was just so confused with this. What do you mean by a German-based model? Like, I usually like I have seen like German-based cars, but suddenly you say German-based LLMs, like LLM models. Suddenly, not like doesn't make sense. Okay, maybe yeah, that is German-based. Indexing with OpenSearch, the extracted text, embeddings, and additional features are stored in OpenSearch index, which makes the document retrievable really fast. Okay, that's cool. We have set up a hybrid search pipeline that uses both the text embedding and text and embeddings to find exactly the right documents when you ask a question. Okay, we have set up a hybrid search pipeline that uses both text and embeddings to find exactly the right documents when you ask a question. Okay, that's really cool. Like when you ask a question, you're not going through every like you're not going to scan through every like you don't need to implement something to scan through every text. OpenSearch does that for you in some way. Like so, you OpenSearch have an index. It quickly set up all the like things that actually related. This is really good. Indexing with OpenSearch. TP setup hybrid search. We configure a search pipeline with normalization processor. Hybrid, we configure a search pipeline with normalization processor for OpenSearch for smooth hybrid retrieval. Bonus, all of this runs locally on a Docker for total privacy. Okay, that's cool. Hybrid search, when you ask a question, the system converts it into embeddings and queries, open search with the embeddings as well as for the user text using hybrid search. It retrieves the top 5 chunks of text that are most relevant to a query and passes them to the LLM. It retrieves top 5 chunks of text that are most relevant to a query and passes to them to the LLMs. So it finds the text that are relevant, like 5 most chunks that are relevant, and it passes to the LLM, which is powered by Olama. Okay, Olama is basically LLMs, sorry, Llama models. Olama is running locally too, so no cloud worries. prompt template and Olama. Finally, with retrieve chunks act as the context for the LLM, and with the design prompt, the LLM provides an answer to your questions without having to go through the loads of documents. Voila, that's it. Building your own local rack system isn't just fun side project. It's genuinely helpful for managing private documents while keeping everything secure and offline. With tools like OpenSearch, Olama, PyTesseract, and Sentence Transformer, you can create your own very AI assistant that respects your privacy. So I think all these are also free for free. I guess OpenSearch is for free. Okay. Yeah, I think it's for free. Uh, in part two, we'll work through the actual complete code to set up the system on your local machine. We'll cover how to run the run and configure the hybrid search locally using Docker. Run the configure and load Docker, integrate PyTestRec to handle the scan documents, set up text chunking generation, build a Streamlit UI for uploading documents and chatting with the LLM, set up retrieval cycle. If you are excited about building your own local rack system, want to dive into code, and stay tuned for the next post as well. We'll walk through the steps. We'll cover everything from setting up the Docker and with OpenSearch to build the Streamlit integrating test drive. Don't miss out. Subscribe with Jam with AI for updates and to support our work. And hey, if you found this post useful or know someone who might benefit from building their own private system, feel free to share it with your friends and community. Let's spread the AI magic. Of course, I will link this. I think you can. Thanks, Sean, leaving you with your funny video that takes you through the journey of building the system in a day. Music, please. What's the point of being in an AI if it can't simply? Okay, that's very cool. Yeah, I like. Actually, I kind of like the marketing aspect of it as well. Like, you can check my post and create mutual colors if it align to goals. Cool. I'm definitely going to the second one as well. I really like the first one. Hello, main lib. I think they're asking league. Okay, lib. I think hello. Welcome to the part two of our journey to create a local LLM based uh, retrieval augmented generation system. In part one, we introduced the vision, a privacy friendly, high tech way to manage your personal documents using state of the art all on your machine. In this blog, we'll walk you through the setup process, covering everything from installing Docker and configuring OpenSearch to integrating by Tesseract for documents OCR and generating embeddings with sentence transformer. By the end of, you will probably have a functional local rack system that's already ready to handle all your documents search needs. Open search a Olama. Okay. Okay, this is a pop of girls. Open search Olama LLM OCR embeddings, and then poof, you have the jam with AI. No, the personal document assistant. uh, This block will build on the foundation we laid on part one. If you are just joining us, it's worth giving that quick read for the context. Now let's dive into the setup. Setting up the prerequisites before you go to the code. Let's get the tools we need. Each of these steps will help Create the environment required to run our rack system. Install Docker. Docker is essential here because it allows us to run OpenSearch locally in an isolated Docker environment. Docker will act as the bone for storing, indexing, and retrieving embeddings. Following the following this installation guide to install Docker on your machine, I think this will actually get me to the Docker. Yeah, Docker based. Yes, that's what I thought. To install the Docker on your machine, after the installation, confirm Docker is running by typing in command Docker version. If Docker is up, you are ready to roll. Install Olama. Olama is a fantastic for running language models locally without requiring cloud. With Olama, you can play around with various LLMs to see which one suits your needs best. Download and install Olama with this link. Uh, 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 I'm just going to download. I'm not going to do it, but I'm just download it. I won't do it. Confirm. I promise you I won't do it. Confirm it's working by running below in command prompt. Olama version. Let's experiment a bit with Olama models to make sure everything is set up. Try running few models. You can play around with models like Llama 3.222 by typing Olama. Chat a bit. Want to explore more? Check out the other models in the Olama library. You can even use the Olama chatbot to experiment with conversational AI. Set up OpenSearch and OpenSearch dashboard. OpenSearch is a vector DB where we'll store our document embeddings. Enabling powerful semantic search capabilities, we'll use Docker to run both OpenSearch and its dashboard locally. Pull OpenSearch and OpenSearch dashboards to start. Pull Docker images for both OpenSearch and OpenSearch dashboard. Docker pull OpenSearch project OpenSearch 2.11.0. Docker pull OpenSearch dashboards. So you are pulling it. I'm pretty new to this. Run OpenSearch and dashboard containers to start OpenSearch. Docker run d name OpenSearch, the portal, then the discovery type, single node, of course. I am not sure what that means. Disable security plugin true. Why am I disabling the security plugin? Of course, I hope this is not a hacking stuff. Like they didn't write this. I mean, this. I thought this guys were just into marketing. Then to launch the dashboard, Docker run d names OpenSearch. Again, there is another portal that you have port number that you have to give. I think MySpace is basically portal. Link OpenSearch host, OpenSearch 9200, which is basically this. So you connect this. I don't know how this Docker runs. Okay, of the container you give this open. Okay, maybe since the container is running locally, that's why we are disabling this to true. Disabling this, disable security dashboards. Of course, I think that's the reason. OpenSearch dashboards to 11. So that's the actually the. I think both have the same version number. They didn't run one top. I think they release everything at the same time. It makes sense, of course. Visit local 5601, which is this one, in your browser, and to access the OpenSearch dashboard. If you see the dashboard, you are all set up. Hybrid enable hybrid search in OpenSearch. Okay, hybrid search combines traditional search techniques like BM25. I'm not sure what's BM25. Of course, okay, I'll just go with this. That is, it's like it's what Google does. Sorry, does with vector-based semantic search. I know what's a vector-based semantic search. It's basically you are having a vector like this. Is that a pen like highlighter? There is highlighter. Can I use highlighter? Like no. Is there a pen like? Is it a pen? Oh, I like. Can't there be a like pen? I think there should be right. Like oh yeah. See. Oh okay. I already had one. I just removed it. Like it was like second nature to me. Sorry. I hope I go to the correct one here. Crypto. I think this is yeah. That's not mine. Do you guys remember what was his name? Page marker. Somehow it's okay. That's cool. Can I delete it? Oh, yes. So vector is basically, let's say you have a word like this word. Okay, I just wrote the word, and and there's a point in some plane like this. uh, of course this word will be changed into a number like this, like 0.1, and that will be represented in this graph. And when you are searching another word like some other word, these are like semantic search, right? Like it's not actually like this could be a paragraph as well, so it will also have some numbers which is basically vectors, and that will be somewhere around here. So if they are nearby, that means they're basically like similar to each other. That's the meaning of it, right? So yeah. Yep. I hope the I can keep it, I guess. Can I just okay? uh, Guys, I assure you I'm not going to use Olama. Just assure you. Okay, I just hit something else. Okay. Okay. Okay, I can get removed, or yeah, I can do it. Enable hybrid search. Okay, vector based semantic search. So as I explained here, this approach improves the accuracy of results by leveraging both text relevance and embeddings. Leveraging text relevance and embeddings to set up. So the basic thing is usually when we are searching, traditional search, you search with the keywords, but here in the vector based semantic search, semantic basically means the meaning of it. So we are searching by the meaning of it, not just the words or the keywords. But of course hybrid means basically means we are using both of them. I'm not sure up to what percentage, yeah, but that's the meaning of it. This approach improves the accuracy of the search results by leveraging both text relevance, okay, and text relevance and the embeddings. To set up the hybrid search, we'll define a pipeline in OpenSearch that normalizes and combines the scores from BM25 and KNN search. I'm not sure what this means, but I think that's they are just search using the keywords. Create hybrid search pipeline. Run the following command in your terminal: curl export local is 9200. Is it something coming here? I don't know. Yes, yeah. So basically, it's the OpenSearch service, I guess. OpenSearch search pipeline, NLP search pipeline. I think you give the heads here. Content type, application JSON minus D, uh, dash D. Description, post processor for hybrid search. So this is coming after the hybrid search. Phase results processes, normalization processes, normalization technique min max, combination technique arithmetic mean, parameters weight 0.3, 0.7. I'm not sure, I don't get the gist of it, or I don't even understand it. But if you are to, okay, if we are to just think of it, phase results processes, phase results processes. So this is happening after the search, and this phase search processes, and there is only one processes. So the processor that we are using is normalization processor, and within that normalization processor we have a technique called min max. So the combination is we are using the technique again, same, I think, like this is normalized. For normalization we are using this technique, and within this you are also combining arithmetic mean. Okay, parameters are like you have weights of 0.3 and 0.7. I'm not sure how what it makes sense, but this is the like kind of the gist of it. Or open search dashboard, go to dev tools, paste the below JSON and hit run. This pipeline will send essential for blending the BM25 and semantic scores for improved search quality. BM25 and semantic search score improved search quality. Okay, that's cool. Put I have to open the go to the open search model, and you have to go to this, and you have to paste just this search pipeline. NLP pipeline is the same thing, I guess. So yeah, the description all those same, yeah. Just export, you can do this both way. For more details, check the OpenSearch docs on normalization processes. OpenSearch is coming up with many features to support RAG systems, and you can check out the documentation here. For now we are keeping it simple. Install Python 3.11 and set up a virtual environment. I'm not used to Python. I also just wonder what this virtual environment is it like some like, since Python doesn't have like Node.js, an environment to run, it's using as a virtual environment. We're using Python 3.11 for this project. If it's not installed, grab it here to keep things clean. Create a virtual environment for this project. Okay, to keep this clean. Okay, I think basically what they are actually doing is like, of course, if they are using the word term clean, basically means this is our inside a computer. Instead of using the computer's memory and all these things, we are using a virtual machine, virtual environment, kind of like a virtual environment, and all those things that you install, the Python will be installed within it. And when this is gone, I think the Python installation will also be gone. I'm not sure. Like I'm just thinking out loud. Uh, why do you have to be? I think maybe the Python can actually affect the the operating levels. I'm not sure. I'm just thinking out loud. Setting up the code and running the application with all our tools in place. Let's get the Google code and start building our local rack system. Follow these steps to bring AI powered document assistant to life. Follow these steps to bring your AI powered document assistant to life. Clone. Uh, okay, let's code, start building our rack system, follow these steps and AA to life. Okay, clone the GitHub repository, get the code from our GitHub repo. Okay, jam with AI, build your local .git, build your local system. Okay, that's the system. Okay, this repository contains all the code we need, including a Streamlit app, setup files, and everything for open source integration. Install the dependencies with your virtual environment activated. Install the required Python packages by running pip install -r requirements.txt. This will install all the necessary libraries such as Streamlit for the UI, Sentence Transformer for embeddings, Streamlit for the UI, Sentence Transformer for embeddings, PyTracer for OCR, and more. Configure constants in constants.py. Now it's time for you to set up the key configuration options in SRC Constants Py. This file allows you to customize the rack systems to your specific needs. Here's a quick guide to the main settings. Embeddings model path. Define the path to your chosen embedding model. We recommend downloading the model like a model like Sentence Transformer or MPNet based version 2 from Hugging Face, and say this is the German based model, from Hugging Face and saving it in a folder named embedding model. This reduces the loading time when the app starts. Alternatively, you can set it to the Hugging Face model. Example, embedding models, sentence transformers, embedding dimension. This is the dimensionality of the embedding model you are using. For instance, if you're using all MPNet based version 2, this set this to 768. If you're using smaller model like all mini L1 version 2, you may set this to 384. Text chunk size. Define the maximum number of characters per text chunk. A smaller chunk size of 300 can improve retrieval accuracy but may increase processing time. Adjust this based on the embedding model's input size and the LLM's context window and the nature of your documents. Olama model name. Set the name of the LLM you want to use with Olama. This could be something like LLM 321B or any model available in Olama's library. Feel free to customize these constants based on your needs. These settings give you the control over the model sections, text chunking, and other core functionalities. Launch Streamlit application. Now that everything is configured, let's launch the application and see it in action. Run the following command: Streamlit run welcome pi. Open your browser and navigate to the edge. Local host 8501 to the access the app. Initially, you need to wait for the background models to be loaded or downloaded for the first time. Once the models are loaded, the interface should now be ready for document uploads and queries. Exploring the application, a tour of features. Congratulations, your local rack system is now up and running. Here's how to make most of it. Uploading documents. The first step is to upload your document. Simply drag and drop a PDF file and the system will handle everything from OCR to text chunking and embedding generation. These processed chunks and their embeddings are indexed in OpenSearch for fast and accurate retrieval. Interacting with your chatbot. With your documents uploaded, you can now start interacting with chatbot. This isn't just a simple chat feature, it's a powerful document assistant. You can ask questions about your documents and the system will retrieve relevant chunks to inform the model's response. Enable rack model mode. check the box to turn the retrieval augmented generation, which means the LLM will use context from your documents to generate more accurate answers. Adjust search settings. Try tweaking the number of top search results and temperature of the LLM. Experimenting with these settings can help you find the perfect balance between accuracy and creativity. Advanced customization ideas. And I think that's great. Congratulations on setting up your very own local privacy friendly rack system. But remember, what we have built here is just the beginning. The basic setup can be adapted and enhanced to meet a wide range of use cases, making it as complex or as focused as you need. Here are some exciting directions you could take this project. Experiment with larger LLMs. While smaller LLMs are faster and efficient, larger models can offer better contextual understanding and nuanced answer. Test out larger LLMs in Olama to see how they handle your document queries. I'm not sure like we can do it with all the computers. I'm not sure. It might need some GPU memory. I'm not sure, but it might need. I'm pretty new to the LLMs world, so I think we might need like a larger computing resource. Use fine-tune or specialized embeddings for improved retrieval accuracy. Consider fine-tuning your embedding models or using models specifically designed for your business domain and language of the text. This could enhance the relevance of use fine tune or specialized embeddings for improved retrieval accuracy. Consider fine tuning embedding models or using models specifically designed for your business domain or language of the text. This could enhance the relevance of retrieved documents. Customize OCR for enhanced text extraction. For OCR process in SRC OCR Pi can be modified to use the alternative OCR tools or pre-processing steps. If your documents include tables, graphs, or the other complex structures, this could improve the quality of extracted text. Customize your OCR for enhanced. Okay. The OCR processes in SRC OCR Pi can be modified to use alternative OCR tools and or pre-processing steps. If your document includes tables, graphs, or other complex structures, this could improve the quality of extracted text. Experiment with different chunking method. Adjusting the chunking method in pages upload document pi can help refine how text is split, which impacts retrieval accuracy. For example, smaller chunks can be better for pinpointing specific information, while larger chunks may preserve more context. uh, so yeah, of course, if you are like, let's say you have paragraph and you are like chunking really small, and it's good for like pinpointing like a separate point, a specific point. But to have a contextual, like have a bird eye view of the documents, you better go for an uh, you should go for an large chunks chunking. Add metadata to open search for advanced querying. Enhance the search experience by adding rich metadata such as entity extraction, page numbers, document summaries, and author names. This metadata can be indexed in open search, enabling even more powerful and targeted searches. Customize the prompt template. The prompt template in SRC ChatPy determines how text and chat history are structured for the LLM. Experiment with different prompt formats to guide the model in providing clearer, more relevant responses. Consider expanding your streamlit by using more advanced UI frameworks for chat interfaces. For instance, check out the chatbot UI by Mackay Wrigley, a React based interface you can customize to enhance your user experience. This could give you application a polished, user friendly interface tailored to your needs. These are just some of the ways to extend your functionality of your rack system, whether it's adapting to pipeline for specific business application, enhancing the user interface, or integrating new ML techniques. The possibilities are endless. Use this setup as your framework and explore the full potential of combining with private document management. With each customization and improvement, you'll transform this basic framework into a tool that's uniquely yours. Dive in, explore, and make it your own. Happy building. I think this is a really good tutorial, really simple, and they don't just like, I think this is a really good way. Like they gave you the source code and they don't put the source code here. They just give you the instructions, and they at last like, hey, this is the basic thing. And if you want to improve it, of course you won't improve it. This is just the basic model, and they give you the idea of like they give you the how you can improve it as well. I think this is really great. I think this is how a tutorial should be. I don't know. Maybe I just downloaded it. I just downloaded the Olama. I might try. If I try, I might, Okay, that's it. Peace.